Okay, so a lot of what we talk about in the backup architecture projects is moving the bottleneck. And what does that mean? So a lot of companies have the traditional Gen 1 architecture for backup, right? So you have a master server brokering data into a disk target, often disk and tape targets. So it's pretty common right now in the field to see disk is disk or non-deduplicated BTL deployed here. And in all realities, when you look at it, the throughput for these devices isn't that high, maybe 200 to 300 megs per second. For tape, you might have 200 or 300 megs per second for new tape, but old tape may be significantly less, and especially if you're trying to stream and have sequential writing into tape, you essentially have a bottleneck. Even though the devices can move really fast, you're not able to stream data to them quickly. So when you look at Gen 2 deduplicated disk architectures, the throughputs, and a lot of architectures can scale up into multiple gigs per second if you have a lot of BTL instances and nodes. So one thing to think about is where does the bottleneck move? So in your traditional Gen 1 architecture, the bottlenecks are often around disk and tape. And if you start thinking about re-architecting with deduplicated storage, where does that bottleneck go? So you have to start looking at different things like, are your master or media server nodes, it depends on the backup app, but are your backup data movers equipped to handle more I/O load as it's inbound? Also, are your network links into your core network switch layers sufficient to handle additional workload if you put a really fast device in here that can move, hundreds of megs per second or gigs per second? Are you going to have bottlenecks at the network layer? Also, if you have a flat VLAN, do you have any saturation issues currently? Or do you have VLANs that are saturated or not? Do you need VLANs? And then if you think about the bottleneck moving all the way upstream to your client base, so Windows, Unix, Exchange, etc. type clients, the optimal bottleneck is how fast these clients can actually write. So when you look at Gen 1 architectures, it was all about just trying to make this slow stuff at downstream in the backup infrastructure work and work as fast as possible. If you're reducing all kinds of complexity here and putting in fast devices, you really have to look at re-architecting the server, network, and also look at some upstream considerations at the client level too.